Session 31 here is now going to be showing us some strategies that we can use to help create equivalent equations, and that the purpose for creating equivalent equations is so that we can solve the original equation that we were given to start with. Now, to illustrate this example, I'm going to borrow the scale idea, the weights on a scale, to show that both sides of an equation must balance. And I borrowed this idea from the textbook. I thought it was a very, very good illustration of how to solve algebra problems, algebra equations. Okay, here's the situation. On the left-hand side of my scale, I have 3 pumpkins and I have 2 1-pound weights. On the right-hand side of my scale, I have 11 1-pound weights. And at this point, I'm telling you that both sides of this scale are in balance. And I'm also telling you that each of these 3 pumpkins weigh the same amount. They're identical pumpkins and they weigh the same. So the question then becomes, how heavy is each pumpkin? Well, let's take a look once again visually. On the left-hand side, we have 3 pumpkins and 2 1-pound weights. On the right-hand side, we have 11 1-pound weights, and they're in balance with each other. So what I've done then is I've come down and I've written an equation to represent what we have here on our scale. We have 3 pumpkins that are identical to each other and weigh the same. So I came down and wrote 3p. 3 times p. P standing for pumpkin. So I know that the weight of those 3 pumpkins plus 2 1-pound weights, 3p plus 2, is going to equal my 11-pound weights. And another way of thinking of this equal sign is that both sides of the equation balance each other. The 3p plus the 2 on the left-hand side of the equation balances with the 11 on the right-hand side of the equation. So using algebra, how are we going to figure out what the weight of each of these pumpkins are? Well, we could do it in our head because this problem is simple enough that we could probably do it in our head. But the majority of algebra problems cannot be easily done in your head. So let's go ahead and work it out. Now remember, what our strategy here to do is to get our variable p all by itself. Well, a couple of different operations are going on with p. The first thing that you see is that p is being multiplied by 3. Now on the same side of the equation where the p is, which is the left-hand side of the equation, we also see that 2 is being added to it. Well, what we want to do is to undo these operations that are going on the same side of the equation that my p is, because ultimately what I want is to get the letter p, the variable p, all by itself here on the left-hand side of the equation. And once again, the way we do that, the strategy we use is that we undo each of the operations that we have here on this side of the equation where our variable is. Okay, so what we're going to do then is we're going to start with this plus 2. Well, what does this plus 2 represent? It represents these 2 1-pound weights up here. Well, this 2 is being added. So how do we undo addition? What is the inverse of addition? Well, the inverse of addition is subtraction. So to undo this addition by 2, we need to subtract by 2. So I'm going to come here, I'm going to cross out these 2 1-pound weights. Well, if I cross out those 2 1-pound weights on the left-hand side, what do I have to do on the right-hand side to keep these 2 sides in balance with each other? Well, if I cross out 2 on the left, if I subtract 2 on the left, I also have to come over here and subtract 2 on the right. So then if I go 3p plus 2 and then I subtract 2, what am I left with on the left-hand side? I'm left with 3p. Because the plus 2 and the subtraction of 2 cancel each other out and give me a 0. And 3p plus 0 is just 3p. So on the left-hand side of the equation, I have subtracted 2. 3p plus 2 minus 2 is leaving me with 3p. Well, I also have to come to the right-hand side of the equation and subtract 2. Well, what's the 11 minus 2? 11 minus 2 is 9. So at this point now, what I'm left with on the left-hand side in my weight, in my scale, are 3 pumpkins. And that's what the 3p is here. 3 pumpkins. On the right-hand side, I'm left with 9 1-pound weights. So the equation I'm left with is 3p equals 9. What operation is still going on with the p, with my variable? Well, right now it's being multiplied by 3. So how do we undo multiplication? What is the inverse of multiplication? The inverse of multiplication is division. So if we divide both sides by 3, what will that give us? Well, if we go 3p and divide it by 3, that leaves us just a p. And if we come over here on the right-hand side, because remember we have to do the same thing to each side. If we divide the left-hand side by 3 to keep things in balance, we also have to divide the right-hand side by 3. Well, what is 9 divided by 3? Well, 9 divided by 3 is 3. So this time around, instead of crossing out, I'm going to just go ahead and erase. Once again, we divided both sides by 3. Well, what is 3 pumpkins divided by 3? Well, 3 divided by 3 is 1. So after we've divided by 3 here on our left-hand side, we're left with 1 pumpkin. And remember, these weights have been canceled out as well. They're not there either. After dividing the left-hand side by 3, I've now got to come over and divide the right-hand side by 3. Well, once again, I'm going to go ahead now and erase these 2 that were crossed out from before. We are left with 9 1-pound weights. And if we divide that by 3, how many 1-pound weights are left? Well, what's 9 divided by 3? 9 divided by 3 is 3. So take this and remove those 6 1-pound weights. After dividing this side by 3, I'm now left with 3 1-pound weights. On the left-hand side, I'm left with 1 pumpkin. These two sides are still in balance with each other, because whatever operation we did to the left-hand side on the balance, we did the same operation on the right-hand side of the balance. And by doing that, it kept both sides in balance with each other. So at the very end now, we're left with p is equal to 3. Is p all by itself now on the left-hand side of the equation? Yes, it is. And then over on the right-hand side of the equation, we have 3. So what is the weight of 1 pumpkin? The weight of each pumpkin is 3 pounds. How can we double check to make sure that's accurate? Well, let's take our 3 and stick it right back into our original equation. Our original equation was 3p plus 2 equals 11. Well, p is equal to 3. 3 times 3 is 9. 9 plus 2 is 11. And 11 does, in fact, equal 11. So we can see here now that the weight of each pumpkin was 3. And we solved this equation by undoing the operations that were on the same side of the equation that our variable was on, so that we could then be left in our final step with the variable all by itself. And once again, the weight scale is the visual illustration of what's going on. That scale is an excellent example to keep track of for the remainder of your algebra career, because whatever you do in algebra to one side of the equation, to keep things in balance on the other side of the equation, you got to do the same thing to both sides of the equations at each step that you take. Okay, well, let's see if we can quickly solve these two equations here, and then we'll go to our review points. Here's one equation, 6x equals minus 12. What we're trying to do is get the variable x all by itself. Well, right now the x is being multiplied by 6. So how do we undo multiplication? We undo it by its inverse. Its inverse is division. So since our x is being multiplied by 6, to undo that we have to divide by 6. Well, if I divide the left-hand side of the equation by 6, to keep things in balance, I have to go to the right-hand side of the equation and also divide by 6. We now calculate it out. What is 6x divided by 6 going to equal? Well, it equals x. What is minus 12 divided by 6 equal? Well, that equals minus 2. Remember, a negative divided by a positive gives us a negative answer. 12 divided by 6 is 2. A negative divided by a positive is negative. Negative 2 is our answer. Well, if I were to stick that back into our original equation is 6x equals minus 12. Stick a minus 2 in there. 6 times minus 2 is minus 12. Does minus 12 equal minus 12? Yes, it does. So our answer checks out here. Okay, we're going to take a look at another algebra problem, but this has an extra step to it. Once again, we're trying to get the x, the variable, by itself. Well, it's on the left-hand side of the equation. It's being multiplied by 2, but then that answer is then being added to a 6. So the first thing that we want to do here is we want to undo this addition that's going on. How do we undo addition? We undo it by subtracting. So since we added 6 up here, or we had a plus 6 up here, we now need to subtract 6. If we're going to subtract 6 from the left side, we also need to subtract it from the right side. So what is 2x plus 6 minus 6? Well, that's just simply 2x. And then what is 12 minus 6? Well, that is 6. So at this stage now we're left with a simpler equation. 2x equals 6. But our x is not yet by itself. It's being multiplied by 2. So how are we going to get the x by itself? Well, if it's being multiplied by 2, we have to do the inverse of multiplication, which is division. So since we have a multiplication by 2 here, to undo that, we divide by 2. But if we divide the left-hand side of the equation by 2, what do we have to do to the right-hand side of the equation to keep things in balance? Well, we also have to divide it by 2. Okay, now we're left on the left-hand side with 2x divided by 2. Well, what does 2x divided by 2 equal? It just equals x. 2x divided by 2 is x. On the right-hand side of the equation, what does 6 divided by 3, or excuse me, 6 divided by 2 equal? Well, it equals 3. At this point, is the x all by itself on one side of the equation? Yes. And on the other side of the equation, it now tells us what the value of x is. X is 3. How do we check ourselves? Well, we put the 3 back into our original equation. Our original equation is 2x plus 6 equals 12. X is 3. Stick it back in here. What's 2 times 3? 2 times 3 is 6. 6 plus 6 is 12. Does 12 equal 12? Yes, it does. Therefore, 3 is the solution to this problem. Okay, quickly then, on our review page, when solving equations in algebra, you must keep both sides of the equation in perfect balance as you work out the steps to find the solutions. And then lastly, to keep both sides of the equation in balance as you're trying to solve it, you must do the same thing to both sides of the equation. That'll wrap up then session 31 on equivalent equations.